What's happening, potato heads? I just wanted to take some time and document the progression of my Chaos Box tone generator. It's been, gosh, about 4 years now since I started working on this. When I first, back in the day, got initially turned on to the Arduino, and it's been a lot of fun. I think the end product that we've got now is pretty cool. It's been a lot of headaches, but mostly it's been a lot of fun coming up with some cool new stuff to tinker around with. So just to get started here, the entire thing is basically run off of the chip and the software that goes with the Arduino, which is right here. Is a cool little microcontroller, an open source project written, debugged, supported by Massimo Banzi, David Cuartielles, Igoe, Gianluca Martino, and David Mellis. And yeah, they pretty much developed this microcontroller and the software that runs the internal logic of it. So what I have here is basically a breadboarding prototype of what it takes to run the noise generator. This isn't obviously the original one, but it's kind of similar idea. So once I had all this stuff plugged in, I started to tinker around with it more. And what I wanted to do was put it into some kind of a box, so I didn't have to worry about any of the stuff becoming unplugged from the breadboard. So this is basically the first one I made. Most of the components here have been, reappropriated, and it's been gutted to use on other stuff. But you can see in here how I would solder all sorts of stuff onto a circuit board I got from Radio Shack, and then all these wires would plug into the Arduino. And there was knobs here that controlled the tone, and buttons, and basically it didn't have much shape to any of the sound. It was pretty much just a noise maker. It made just a lot of noise, and there's no rhyme or reason to much of it, but it got a little better. So eventually I wanted to, instead of having to use my Arduino, which I was always using for other stuff, I figured out how to build one myself out of scratch and use the actual chip that ran it to run my program. So what I did was I got copper board, and I came up with the circuit that I wanted to have, and I printed it out on laser paper and ironed it onto the copper board. And once it was ironed on, you could wash off the paper. Paper would come off, but the black of the laser toner would stay on there. And then I dipped the chip into a bath of muriatic acid, which burned away all of the copper except for where the black was. You could kind of see here, this is a terrible failure of a chip that I tried to make, but you can pretty much see it without the copper burned off. So once I had one of those made, I'd wired it all up, and then I started playing around with putting it into an actual project box. This is one of the original ones in the came in a project box, but again, I've reappropriated a lot of the components and stuff from in here, but you can kind of see in there how it was set up. Again, it had all the, here's where the knobs were, and then the pitches here, these buttons would change the pitch of the noise coming out, and then come out through the speaker. After that, I kind of wanted to have some kind of actual tones, so I got together with my friend Mark, and he actually knows quite a bit about music and music theory and all that kind of cool stuff, which I don't have the slightest idea about. And the cool thing about Arduino is it comes with a tone library, or a pitch library, and it basically has a whole bunch of number and values that translate into an actual tone that you can put out through a speaker. Now, they're all pretty random tones, so what my friend Mark did was he went through all of the tones and he organized a list of actual scales, something like the blues scale, for instance, and we started loading that into the actual tone generator. So the next one we had here gets a little bit more fancy, and there was we added a delay, which would pause the playback, a high note and then a low note, and then the program that I wrote would randomize in between those two values and then pick an actual tone that was a real tone from a scale and play it out. And we also added this kind of a guitar pickup here, so this would allow us to switch in between the actual scales. And that was really cool because, I don't know, it was just cool. So the next one kind of started to get a little bit more fancy, and this particular one, I reappropriated an old Cisco phone and put the speaker behind here, and you can kind of see some of the wiring in there. Got some actual knobs on there, and what we did on this one was to have a button that was a quick play, and that would again, it would pick from the two high value and low value, generate a tone, and then it would play it really quickly. And on this side there was a constant play, so you could push that in or push it out, and if it was down it would continue to keep on playing the note, and then you could turn the dial and it would go up and down the scale. And we've got the scale pick over here, and also on this one we started to have an analog output, so you could switch. Instead of playing on the onboard speaker, you could switch this over and it would actually output it, so you could go to like a PA or like your computer speakers or whatever. So I guess at that point I was still making using the copper board to build my PCB and my circuit, and it was really time consuming. It took a lot of time, and it was, I don't know, it was really smelly. The muriatic acid was really gross, and I don't know, it just took a lot of time, so I got tired of doing that. So I sent my design over to China, and they printed the actual circuit board for me, and with some help of a friend of mine, he actually wrote he actually came up with the actual design, and so that they could actually fabricate this board over there. And I got a couple hundred of those, and I'm still using them today. They're awesome because it cuts down on having to actually build that board. So what I could do is just take all the components I need and plug them right into here, solder them all up, and we're good to go. So now I was saving time on that. I started to work more on developing a better plan for this, and this is another evolutionary step. We eliminated the guitar jack that would allow us to select through only 4 scales, and added a potentiometer on the back here, a knob that allows, essentially, we can pick over 1,000 scales, but I think right now we only have 10. And also added the ability to put a sustain in there so that you could play a note, even if it was the fast note. If the sustain was up, it would hold that note and keep playing it until you changed the dial and selected a different note. And that was really cool. Over here, the box starts to get a little bit bigger, so I could work with more wires and stuff inside. This is actually kind of the same as the last one that you just saw, but let me see what's different about this one. Not much, it's just a different box, but it's starting, you can see it looks a little bit cleaner. It's not quite as crazy looking as the previous ones. It's got all the same stuff on it: low note, high note, fast play, constant play, sustain. This is the power light. This is a light that comes on to let you know you're playing a tone. The analog out to speaker, and on switch, which also controls the scale. So from there, it kind of got a little crazier and got more complicated. So here's the next step in the evolutionary process, where I kept all of those same components from the previous ones and decided I was going to add 8 buttons here to step up the actual scale that was being generated between the high and the low note selector. So when you hit one of these buttons, it would jump it up in pitch from the original one, and that was actually really cool. It added a new cool effect to it, and it actually started to seem like some kind of actual musical instrument, not just something that's making noise. So the next step here is this fella, which I kind of just decided I'd like to see the wires on the inside, and so I got plexiglass and cut out the square shape that I needed for it, and just soldered everything up the way it normally was, and you've got all our usual components here, and the sustain, speaker, here's the delay knob, the play indicator, the power indicator, fast play, constant play. But this one I only decided that eight tones was kind of overkill, so I dropped it down to 4, and that would free up some other space on the actual pinout of the microcontroller chip to do some other stuff, which I have here in the next one. Here's the final version that I just completed this afternoon, actually. This one's actually pretty complicated. It's got all the same stuff as the previous ones. The high note selector, low note selector, power indicator, play. This light here shows you that the speaker is being used. You've got this selects to go over to analog out, and that light will tell you that you're going to analog out. And here's our scale selector and the power switch. And again, we've got 4 buttons that jump the selected tone up in value, and fast play, constant play. Here's our sustain. But down here, what we've done is add a cool new feature, which is awesome, and it kind of brings into play my my variable length array theory that I had to kind of, rack my brain to figure out how I was going to get this to work, because this essentially is a sampler. What it does is, when you have the record going, it'll record whatever tone you're being played and store that in an array, and then once you stop, you can hit the play button and it'll loop through that array depending on the length of it, and then when it comes to the end, which is a predefined number that cannot actually be achieved by the potentiometer, it'll stop play, loop, and go back around from the beginning. And that's actually really cool. So I've got this here allows it to constantly play. This one's to quick play, and then over here is a erase. Well, that's pretty much it. I'm going to make a video of this guy playing and show that up next. Alright, cheers.